I'm working on the expanding gas experiment, and what we're going to see is what takes up more space, liquids and solids or gases. And the way we're going to do that is we're going to take a liquid and a solid, and we're going to put them together and we're going to turn them into a gas through a chemical reaction. And then we're going to observe how much space they take up. So you've done this experiment before, I'm sure, but you may not have captured the gas to see how much space it takes up. And that's what's going to be different this time. In our book, it says to use an empty 2-liter soda bottle. And I don't buy soda, so I don't have one of those, but I do have a glass gallon bottle, and that's going to work. So I'm going to use that. And it says you need a balloon, and as you guys know, I can't do balloons, so I have a glove instead. And you need a funnel. Oops, forgot my funnel. I'll be right back. Funnel. Five tablespoons of baking soda and enough vinegar to fill 1/4 of the soda bottle. Now, a 2-liter soda bottle is going to have 2 liters worth of liquid in it. 1 liter is 1,000 milliliters. So 2 liters would be 2,000 milliliters. 1/4 of that is a half of a half. So if 2 liters is 2,000 milliliters, half of that is 1,000 milliliters, and half of that is 500 milliliters. So I poured 500 milliliters of vinegar. And I have baking soda here, and we're going to put 5 tablespoons of the baking soda into the glove. And then we're going to pour the vinegar in here, and we're going to carefully tape the glove onto the top without getting the baking soda in. And then we're going to put the glove, lift the glove up and dump the baking soda in. And then the glove will trap all of the gases so we can see how much gas is produced and how much space that gas takes up. All right, let's get started. When you measure your tablespoons of baking soda, make sure that you keep the measurement level so that it's an accurate tablespoon measure. Mine's a little chunky, so I'm having to smush the chunks so I can get a level tablespoon. And make sure you get baking soda, not baking powder, because they're not the same thing. Baking powder has only 1/3 baking soda, and then it's mixed with a powdered acid. And vinegar is an acid, and baking soda is a base. So you'll get a much less of a chemical reaction if you mix it with baking powder. So remember, baking soda and baking powder are not the same thing. When I'm baking, I usually prefer to bake with baking powder, but you always use what your recipe calls for. But I like to invent my own recipes, so my recipes usually call for baking powder. My fingers are getting full. Make sure you don't lose count while you're doing this. Just realized one other material that I am probably going to need, because I don't think I can tear this tape. Yeah, oh, I did. Don't want to get any of the baking soda in yet. You want to make sure that you keep your balloon or your glove with the end of the baking soda in here until you have your balloon or your glove all secured in place. Okay, here we go. I'm going to try to release all the baking soda at once. This is going to be a challenge. So I'm gently working all the baking soda into the palm, out of the fingers and into the palm, so that I can drop it all at once. Ready? There it goes. Oh! I think it might pop. Can you see the top? No, you can't. There's the gas. Oh yeah, it popped. There was so much gas, we popped the glove. Oh wow. Well, that was a good experiment. Okay, so now analyze the data. Which takes up more space? We have the exact same matter. It was the exact same atoms. It's all gone now, but because we lost our gas, it escaped. It popped the glove and escaped. And it was the exact same molecules that were in the vinegar and the baking soda. The question is, which took up more space? Did they take up more space when they were in a liquid form and a solid form, or did they take up more space when they turned into a gas? As when they were in the form of baking soda and vinegar, they were liquid and a solid. And when baking soda and vinegar reacted, they turned into carbon dioxide, which is a gas. So which took up more space, the liquid and the solid, or the gas, carbon dioxide? And then the follow-up question to that is, when we are working with natural gas, sometimes we have to transport it from one place to another. And sometimes we transport it as a gas, but sometimes we transport it as a liquid. And we compress it, we squish it down to make it into a liquid. Why do you think we might do that?